Hello and welcome to Tribe Topper. In this video session, you are going to learn about standing waves. So, what do we mean by a standing wave? So, when an incident wave interferes with its own reflected wave, the result is a standing wave. So, why do we call it a standing wave? Because it just appears to be stationary at the same point and it just goes up and down. It doesn't seem to be traveling left or right. It just goes up and down, jumping up and down, just like you jump a rope. So you are not going either left or right. So when somebody is jumping a rope, it's just a rope which is going up, down, up, down. So that is a standing wave example. So as you can see here in this diagram, that one is a blue wave traveling to the left. One is, so green is the original incident wave traveling to the right, and the blue wave which is traveling to the left, that is the reflected wave. So when this incident wave, it interfered with its own reflected wave because they had the same amplitudes but directions were opposite, so they resulted in a stationary wave. So if we talk of the standing wave on these two strings, how do we say that there are some very important points? They are nodes and antinodes. So as you can see, the green and the blue waves move forward. There are points where the total displacement always remains zero. As you can see, these are the points where the displacement is zero, right? So these points where they interfere such that your resultant amplitude is zero, they are called the nodes. And at other points where the displacement varies between a maximum in one direction and a maximum in the other direction, so that means these points, they are called the antinodes. So the points of maximum displacements are the antinodes and the points of zero displacement are called the nodes. So here this diagram simply shows you that if you tie a string, you fix a string at two ends and connect it to a vibrator, like one end is connected to a vibrator, the string is going to vibrate. So what kind of shapes you are going to get for this string? It can be a single loop, it can be a double loop as shown here, it can be a triple loop. So based on the frequency of this vibration generator, so this generator, you go on changing its frequency, and according to that, the shape of the loops that you're going to get will also keep on changing. So we say when the ends of the string, they're attached to the vibration generator, this oscillates vertically up and down. The reflected wave is going to superimpose the incident wave, right? The wave is traveling from one side to the other and it is going to interfere with its own reflected wave. So we have a stage where we say the frequency of your audio frequency generator, you are increasing it from zero, and eventually you reach a frequency where the string vibrates with a large amplitude in the form of a single loop. So corresponding to this frequency right now, when you're just getting a single loop, we call it as the first harmonic. So this is for n is equal to 1. That's your first harmonic. Now, if the frequency is further increased, the amplitude of the vibrations is going to die, and then you are going to get a new wave in which, until you are like changing the frequency, you will not leave the frequency at of the generator there only when the amplitude has died out. So you have to adjust the frequency of the oscillator so that now you get some vibrations or this loops where you get twice the first harmonic frequency. So that means you have two loops formed. So this is called the second harmonic frequency, so corresponding to n is equal to 2. You can now go on changing and increasing the frequency of the oscillator so that you can get 3 loops, 4 loops, or 5 loops. And accordingly, where you get the 3 loops, like the oscillations die out and then they again generate 3 loops. So that is going to be the third harmonic. And when you have 4 loops, that's going to be the fourth harmonic and fifth harmonic, and so on, right? Now, one thing that you need to understand here is what is the frequency corresponding or the wavelength corresponding to the first harmonic. So, for the first harmonic, you see, if this entire length between which it is fixed, the loop is fixed, that length is L, then this length just contains half of the wavelength because this is half of a loop. This is not a full wave. Like you can actually complete the wave when it goes like this. That's a full wave, right? So this length is just containing half of the loop. Therefore, lambda is twice of L. Now, if we go to the second case where that is second harmonic, you have the single length L, the same length L, now contains two loops. That's a one full wave. So that means within the length L, you have the full wavelength lambda. Similarly, if you go to the third case, n is equal to 3, within that length L, see the length L is fixed, but now you have three loops. So for the third harmonic, you have lambda is being contained, there are 1.5 lambda. So 3 by 2 lambda is contained in the length L. So lambda is 2L by 3. Similarly, for the fourth one, you have two waves contained in the length L. So lambda is L by 2. So this way, as you go on getting the new loops, that means you have the first, second, third, fourth harmonics, your wavelength is also changing. So what do you notice here? So we find out that for the first harmonic, lambda is 2L over 1. For the second harmonic, lambda is equal to L, which means it is 2L over 2. For the third harmonic, lambda is equal to 2L over 3. For the fourth harmonic, lambda is equal to 2L, which means, lambda is equal to L by 2, which means it is 2L by 4. So if you have to write the equation for the wavelength of the nth harmonic, what will be the wavelength of nth harmonic when your string is fixed at two ends? Lambda is going to be 2L over n. As you can see, everywhere you have 2L, but the denominator is 1, 2, 3, 4. So this is the wavelength of the nth harmonic when your string is fixed between two ends. So in this video session, you learnt about the standing waves formed when a string is fixed between two ends. In the next video session, you are going to learn about the standing waves formed when one end is closed and one end is open. So that's all for this video session. Thank you.